Fischer esterification,
with Ryan
and Zach. The mechanism begins with a carboxylic acid, which is protonated with an acid such as sulfuric acid or p-toluene sulfonic acid. The carbonyls, oxygen, lone pairs, add a hydrogen that is donated from your acid. This creates resonance.
Resonance occurs in this molecule when electrons from the carbonyl group move to the positively charged oxygen. This is unfavored due to periodic trends. Electrons are likely to resonate back to a double bond, as a positively charged oxygen is more favored than a carbocation.
Step 2. An alcohol is added to the protonated carboxylic acid. An electron pair from the alcohol's oxygen is attracted to the delta plus of the carbon in the carbonyl, attaching to it and forcing electrons from the double bond between the carbon and the oxygen to move towards the oxygen, creating an alcohol substituent. The tertiary structure that has formed around this carbon is key to this mechanism. Step 3. A base's lone pairs attack and remove the hydrogen from the positively charged oxygen and returns the oxygen to a neutral charge. Caution: use a neutral base to remove the hydrogen, as a positive charge and a negative charge don't mix well. Resulting from this is a carbon attached to an ether and 2 alcohols. Step 4. A second equivalence of acid is added. This time, an alcohol's electron pair attaches to the donated hydrogen, which creates water, a good leaving group. Step 5. The alcohol donates a electron pair to the carbon, reforming the double bond between the alcohol's oxygen and the carbon. This forces the water to leave and returning the carbon back to an sp2 carbon and another positively charged oxygen. This again creates resonance.
The resonance that occurs here is much like that of step 1. The positively charged carbocation that is produced is unfavorable, so resonance only slightly contributes.
Step 6. Finally, a base enters, removing the hydrogen from the positively charged oxygen, resulting in a stable ester. Again, remember to use a neutral base, as positives and negatives don't mix.
Thank you.